mainly the properties of central force. So we have seen the basic properties of central force. Now, after this particular thing, let's try to go for one particular problem, which I have also given you as a homework. So let's try to discuss a very nice potential. This is also central force potential, and that is known as harmonic potential. Okay. So what we have potential VR, and that is nothing but half k r square. So this is our potential, and this is your harmonic potential. And J is the angular momentum which is given. J is nothing but angular momentum. And M is mass of particle. So M is mass. So first question was that plot V effective versus R. So what is your V effective? So V effective is equal to J square upon 2mr square plus VR. And this is nothing but the rotational kinetic energy as a function of R. And this can be written as J square upon 2mr square plus half k r square. So this is our V effective. And when you want to plot this particular V effective versus R, then you can plot it very easily. R is always positive. So you have this particular V effective versus R. And for the, you can see there are two different algebraic function. So here R is inversely proportional to, V is inversely proportional to R square, and here directly proportional to R square. And you can assume that J square upon M and half K is more or less comparable. So what you have basically, if a smaller value of R, you can see this can be neglected. Which one is going to dominate for the smaller value of R? Obviously, this value is going to dominate, because this will be R tends to 0, this will be infinite, and this is very small. So dominate part of the smaller value of R is basically this one. So this is something like J square upon 2mr square. Now, if I am going to plot this particular thing, then this plot is something like this. This is parabolic in nature, and we are just talking about only one coordinate because R is always positive. Now you can see, if you will take the combined effect, then what will happen? This will again go up to some upper level, and this will also go up to some upper level, and your effective potential will be something like this particular dotted line. Everyone is comfortable? So what is your effective potential? So if you want to plot V effective versus R, then this will be something like this. Okay. So this is your V effective versus R. Now, this is your plot. And from this particular plot, what can be conclusion? Which type of orbit can be there? क्या-क्या orbit possible हो सकता है? Anyone?
Circular or elliptical?
Very good. Circular and elliptical. So if you have this sort of energy, suppose this energy is E naught, and this will be your local minima or stable equilibrium point. So for this particular energy, you have circular orbit, and other than all energy, when you are going to shift the energy from this particular circular, you cannot go for the less than E naught, because all region are classical forbidden region. What you have into this region, and this region is nothing but what? Basically elliptical in nature, because, and yes, this will be also equivalent in, for one dimension, this will also equivalent to oscillation, isn't it? Because this point is nothing but what? A stable equilibrium point. Am I correct? So first question was that what will be for the circular orbit. So let's go for a different physical quantities for circular orbit. So first we are just going to calculate the radius of circular orbit. So how you will go for calculating the radius of circular orbit? Obviously, del V effective upon del R must be equal to 0, isn't it? यही होगा ना? और यहां से आपको मिलेगा क्या? What you will get? You will get minus J square upon mr cube plus kr is equal to 0, and from here you have r to the power 4 is equal to J square upon mk, and this r is nothing but r naught, and this value is equal to J square upon mk to the power 1 by 2. So this is your radius for circular orbit, and you can check this second order derivative will be greater than 0. We will also check this particular thing. So why it is a stable equilibrium point. Now next question is that you have to calculate the energy. So what will be energy?
Sir, 1 by 4.
What 1 by 4?
Sir,
Oh, sorry.
Yeah.
Sorry. This is 1 by 4. Good, thank you. And what will be energy for the circular orbit? Energy, any energy can be written as half m r dot square plus j square upon 2m r square plus potential energy, and that potential energy half kr square. So this is your potential, this is your energy, and at the r is equal to r naught, what is going to happen? क्या होगा r is equal to r naught पर?
R dot will be 0.
Very good. So at r is equal to r naught, r dot is equal to 0. Why r dot is equal to 0? Because there is not any radial velocity, because you are moving in a circular track. So there is not any radial velocity. So for r is equal to r naught, r dot is equal to 0, and E can be written as E naught. So we have to calculate this particular value of E naught. So E naught can be given by J square upon 2m r naught square plus half k r naught square. I can easily put the value of r naught here, and you can get the answer. I think you have, somebody have solved it. What will be answer? I think this will be j root under k upon m. ऐसा आ रहा है क्या?
Yes, sir.
Yes. So this will be energy in term of angular momentum. So this is your energy in term of angular momentum. Okay. Good. So this is your energy. Now, next question is that what will be angular frequency for the circular orbit? So can anybody tell me what is the formula for the angular frequency?
Root under del square V effective upon del.
This is not correct answer.
Sir, whatever
Del V upon del R, right?
Very good. So what will be that particular thing? Omega naught जिसे कह रहे हैं, आप अपने कॉपी में जाकर चेक कीजिए. That value is del V upon del R at R is equal to R naught by M R naught. ये है ना? Just check it.
Yes, sir.
ये कहां से आ रहा था? From where you are getting this thing? बताओ. Anyone?
Sir, energy क्वेश्चन से R dot 0 करके.
क्या करके 0 करके?
R
वहां से नहीं आ रहा है. कहां से आ रहा है बताओ?
equal to 0.
Sir, equation of motion से circular
Equation of motion से circular motion means circular orbit means external force is equal to centripetal force. था वहां पर? कल करवाया था?
Yes, sir.
रेडियल पार्ट में आपने न्यूटन्स लॉ ऑफ मोशन लिखा था, और लिखने के बाद आपने देखा था सर्कुलर ऑर्बिट के लिए आर डबल डॉट की वैल्यू 0 हो जाएगी. रिमेंबर दैट थिंग? प्लीज रिवाइज करो, है ना? अगेन आई एम टेलिंग यू व्हाट वाज इक्वेशन. द इक्वेशन वाज एम आर डबल डॉट माइनस आर थीटा डॉट स्क्वायर is equal to FR. And what is this FR? Minus del V upon del R. यही था ना? And this theta is what? Omega at r is equal to r naught. This part is 0, and this is nothing but minus kr. You can see. Are you getting my point? So you can find this particular value. Go and revise this thing. And this particular value is equal to what? Root under k upon m. Everyone is comfortable? Now, if you are going to change the energy, then we have go for elliptical orbit. कैसा मिलेगा चेंज करने से एनर्जी? That is elliptical orbit, है ना? So if you are going to change, and you can only increase energy, you cannot decrease energy from E naught, because all region are what? Classical forbidden region. So you have elliptical orbit. So if you are going to increase this particular thing, then what you will get? What is your angular frequency? यहां पर angular frequency क्या होगा सौरभ? बताओ. Here your angular frequency is del V effective.
Del 2 V effective over del R.
Yes, upon R is equal to R naught. Because this is equivalent to what? Oscillatory motion, and you can assume the motion can be a small oscillation if you are moving about the stable equilibrium point. R is equal to R naught is radius of a circle. This is also a stable equilibrium point. So why you can use the stability analysis and you can easily calculate this particular thing. क्या आंसर आ रहा है? Anybody?
Sir, divided by m.
Divided by m, obviously. क्या आंसर आ रहा है? So
2
you
under
will
root
get.
k upon m.
So you will get 4 and root under k upon m. How you will get it? You will just put this particular value. Second order derivative you can just go from here. यहाँ से derivative ले जाओगे तो क्या होगा? Del square v effective upon del r square. I am just going to take the derivative of this one. So this is 3 j square m r to the power 4 plus k. R to the power 4 की वैल्यू आप यहां से डायरेक्टली पुट कर सकते हो. That will be 4k at r is equal to r naught, and this is your value of r naught. So you can have omega is equal to 4k upon m. Yes, just look at your copy. If you have any doubt, you can ask me. And from one question you can solve. This is one beautiful question. Every theory is just coming to your in this particular problem, isn't it? Okay, chalo.
Yes, sir.
Great. So let's try to go for one more problem. है ना? एक और problem करते हैं. यहाँ तक clear है ये? Just a minute. Chalo. So next problem is also a very interesting one. Just a minute. So it is given that force is given as minus k upon r to the power n. So this is your force. The force is given as minus k upon r to the power n. What you have to do, you have, and this is force, this is not a potential. So always try to make clear. So what is this thing? This thing is nothing, but actually minus del v upon del r is equal to minus k r to the power n. So you can have del v upon del r is equal to k by r to the power n. Okay? Everyone is comfortable? ठीक है ना? Now the question is that find the value of n. फाइंड द वैल्यू ऑफ n सच दैट n की वैल्यू क्या होगी, फाइंड द वैल्यू ऑफ n सच दैट ऑर्बिट इज सर्कुलर as well as stable. So orbit is such that orbit is stable and circular. So this is our problem, है ना, ये हमारा प्रॉब्लम है, इसको हम लोग देखते हैं. So we have to just go for orbit is stable as well as circular. So what is condition for circular orbit? So first what we have to do, we have to go for V effective. What will be V effective? That is nothing but J square upon 2mr square plus VR. And from here we can have, for the circular orbit, let us r is equal to r naught is the radius. So you have del V effective upon del r must be equal to 0. That implies J square minus sign is also there, mr cube plus del V upon del r must be equal to 0. And here we are getting del V upon del r from here. मिल जाएगा ना? Yes, look at here.
Yes, sir.
Yes.
So what is this particular thing? So I can just go for minus sign is obviously there, mr cube plus k by r to the power n must be equal to 0. Minus j square by mr cube plus k by r to the power n must be equal to 0. But this is only condition for circular orbit. We have to also introduce the story of stable orbit, isn't it? हमें इसमें किसकी स्टोरी को इंक्लूड करना पड़ेगा? स्टेबल ऑर्बिट की. So when we are using the story of a stable orbit, then what will happen? बताओ, what is condition?
Del to V effective over del R square
Is
and R
greater
equal
than
to
zero.
R
Very
naught is
good.
greater
Del
than
r
zero.
square must be greater than 0 at r is equal to r naught. So let's try to go for a second derivative to this one. So when you are going for the second derivative, this is 3j square m r to the power 4, and you have to differentiate this one del v upon del r. So that means you have to differentiate this one. So this will give you minus n k r n plus 1. Am I correct? ठीक है ना? And that must be greater than 0. Now you have to talk about n. So what you will just do, you will just write, and please mind it, this j is not known to us. We have just introduced for the sake of concept. So this j is not known to us. So what we can do, we can use this particular condition, and we can write value of j square upon mk from here. लिख सकते क्या? Sorry, j square upon m r cube की वैल्यू लिख सकते, क्या होगा ये? k upon r to the power n. So whole thing can be replaced here. तो पूरी की पूरी चीज को यहां आप रिप्लेस कर दोगे, then you will get 3k upon r to the power n plus 1 minus nk by r to the power n plus 1 must be greater than 0. And from here you can have expression, and that expression is very interesting one. And this is all about 3k minus nk must be greater than 0. So n must be less than 3. So n must be less than 3, then only you can have a stable circular orbit. Everyone is comfortable? Yes or no?
Yes, sir.
ओके.
Yes, sir.
अब देखो एग्जाम में क्या दे सकता है, एग्जाम में आपको इसे ये सब याद करने की जरूरत नहीं है. सो यू विल ऑलवेज सॉल्व दिस टाइप ऑफ प्रॉब्लम. एग्जाम में सम टाइम यहाँ पोटेंशियल दे देगा, सम टाइम दे विल गिव यू फोर्स एज आर n-1 और n+1. सो उसके अकॉर्डिंग आपकी एन की वैल्यू चेंज होती जाएगी. सो ऑलवेज कॉन्शियस रहोगे कि एग्जाम में क्या दे रहा है. ओके, क्लियर है ये? चलो, सो दीज टू प्रॉब्लम आर वेरी इंटरेस्टिंग वन. And now we will go for a next particular very interesting concept, that is differential equation of orbit. So हम लोग ये करते हैं और फिर इसके ऊपर हम लोग प्रॉब्लम सॉल्व करेंगे. ओके, सो लेट्स ट्राई टू गो फॉर व्हाट, डिफरेंशियल इक्वेशन ऑफ ऑर्बिट. यहां तक क्लियर है? Okay, so let's go for again a Newton's law of motion. So we will write Newton's law of motion. And what is this particular Newton's law of motion? You can write m r double dot minus r theta dot square must be equal to Fr. What is Fr? Force in a radial direction, and this is nothing but the acceleration in radial direction. So always try to figure it out, है ना, कि ये क्या है. Now we have, and this is dot here, we have basically theta dot is equal to j upon mr square. So because angular momentum is conserved, you can easily write theta dot is equal to j upon mr square. And if you are writing this particular thing, so what you will get? Mr double dot minus j square upon mr cube is equal to Fr. And this equation is nothing, second order differential equation. When you are going to solve this particular differential equation, अगर आप इस differential equation को solve करते हो, then what you will get? When you are going to solve this particular differential equation, you will get relationship between R and T. किसी भी तरह से solve करते हो, that is different issue. किसे solve करना कितना आसान होगा. Okay. Now, if you are going to solve this particular thing, you will get relationship between R and T. Now, what you have to do? You have to just go for, let's try to solve this one for R and theta. So we will use this particular thing. Look at how we will use it. So this thing can be written as d theta upon dt is equal to j upon mr square. So this thing can be written as d upon dt is equal to j upon mr square d upon d theta. And this is nothing but something like operator. So you can use it just like operator. So if I will put r here, I have to put r here. So this kind of thing is there. Now we have to find d square r upon dt square. So what is this particular value? D square r upon dt square. This can be written as d upon dt, dr upon dt, and this can be written as here. First d upon dt can be written as j upon mr square d upon d theta, and second dr upon dt can be written as j upon mr square dr upon d theta. Clear है ये? Everyone is comfortable? लिख सकते हैं ऐसे?
Yes,
Now,
sir.
what is going to happen? Look at this thing is d square r upon dt square must be equal to, I will keep this thing same like that, j upon mr square, and this is d upon d theta. I can take m outside, and the whole thing is, and this is j square is also there. So 1 upon r square dr upon d theta. Can I write this whole thing in the bracketed term? इस पूरे ब्रैकेट वाले टर्म को क्या आप लिख सकते हो? j square m square 1 upon r square d upon d theta, and this will be d upon d theta minus 1 by r. जरा चेक करो, ऐसे लिख सकते क्या?
Yes.
आया ना? लिख सकते?
Yes, sir.
लिख सकते हैं. And now this will directly apply to here. So you can write d square r upon dt square is equal to j square m square 1 upon r square d square d theta square, minus sign we can take it outside, 1 by r. So now look at what is going to happen. This time part can be replaced with this particular theta part. So when this can be written, I can reduce this particular differential equation. Obviously, this is also second order in time. So we can just go for second order in theta. Let's see what is going to happen. So when we are going to write this particular thing, 1m and 1m is going to cancel out. So we have j square upon m, and second term is 1 upon r square d square d theta square, negative sign is also there, and 1 by r minus j square upon mr cube is equal to fr. So this look little bit clumsy, थोड़ा अजीब सा लग रहा है. So let us try to make it beautiful. So इसको थोड़ा सा beautiful बनाते हैं. How you will make it beautiful? What you will do? You will just take j square upon mr square with the negative sign common. In the bracket, you have d square 1 by r upon d theta square plus, what you will get? 1 by r must be equal to fr. And here you can put u is equal to 1 by r. Then everything can be written in term of u, such that you can remember it nicely. So what is your differential equation of orbit? So this value is minus j square upon m u square, and in the bracket d square u d theta square plus u is equal to f1 by u. Why f1 by u? Why f1 by u? Because r is equal to 1 by u, and this is function of r, and this is very famous differential equation of orbit. So आपको एग्जाम में इतना करने की जरूरत नहीं है. You will always start from here, okay? And you can easily solve different type of problem. And what is beautiful part of this particular second order differential equation? इसका beautiful part क्या है? What is the beautiful part? The beautiful part of this particular second order differential equation is that if you have f, then you can solve this differential equation and you can write the equation of orbit. You can write the u versus theta, and you can finally find the r versus theta. This is one thing. And second thing is that when you have u, you can also discuss what can be your force. आप ये भी डिस्कस कर सकते हो कि आपका फोर्स कैसा होगा. Isn't it? Everyone is
Yes, sir.
comfortable? है ना?
Yes, sir.
So अगर u दिया हुआ है तो f के बारे में बात कर सकते हैं, f दिया हुआ है तो u के बारे में बात कर सकते हैं. So obviously let's try to do some basic problem. करने की कोशिश करें, है ना? चलो, और एग्जाम में इसके ऊपर जेस्ट का ये फेवरेट है, ये जेस्ट में हर एक साल के बाद एक क्वेश्चन आ ही जाता है. Either they will give you force, you have to find u. In general, they will just give you force, you have to just use u. Okay? Okay, let's try to go for it. करें क्या इसे solve? चलो. So first, let us go for very trivial and very simple problem. Let us assume that u is, sorry, r is e to the power theta. कैसा ऑर्बिट होगा ये? r is equal to e to the power theta. Anyone? Which type of orbit can be this? क्या हो रहा है बताओ? स्पाइरल, isn't it? थीटा की वैल्यू जैसे जैसे बढ़ता जाएगा वैसे वैसे आर की वैल्यू क्या होती जा रही है? बढ़ती जा रही है. Isn't it? So from theta is equal to 0, you have r some fixed value and you will increase, that will be going to increase. Anyway, so what you have to do, you have to find what are the nature of force. Suppose this is going to interact with central force, so what will be nature of force? So हमें क्या करना पड़ेगा पहले बताइए. What is your equation? Your equation is minus j square u upon, sorry, u square upon m d square u upon d theta square plus u must be equal to f1 by u. So यहां पर u दिया हुआ है क्या? Yes. 1 by r is equal to e to the power minus theta, and this is nothing but u. So we can put it here. So you can put minus j square e to the power minus 2 theta u square by m, and if you are going to differentiate it twice, you will get the same value, e to the power minus theta plus e to the power minus theta is equal to f1 by u. This is very simple, very trivial, just to understand how to apply this particular problem. So you can have this one, and yes, what is this particular value? क्या होगा ये? Minus 2j square upon m e to the power minus 3 theta is equal to f1 by u. Can I write this thing as minus 2j square upon m e to the power minus theta to the power whole cube is 1 by u? लिख सकते क्या? Yes या no?
Yes, sir.
Yes. And what is e to the power minus theta? U. You can put this whole thing is k. So I can put minus k u to the power cube is f1 by u, and you can write fr is nothing but minus k r to the power cube, where k can be written as 2j square upon m, something like this. But this k is positive quantity. What is significance of negative sign? What is
Force is
significance of
attractive.
negative sign?
Attractive force.
That is attractive in nature. Very good. So that is attractive in nature. So you can see the force is proportional to r to the power cube in this particular case. And yes, the orbit is something like a spiral. So you can use, this is very efficient formula. This is very efficient one. Let's try to go for one more problem. Everyone is comfortable? Chalo.
Yes, sir.
Chalo, let's go for one more problem. So let us assume that a particle is moving in a circle. ठीक है, particle कहाँ move कर रहा है? Circle में, and the trajectory of this circle is also given. This is very nice problem. So this is trajectory of a circle, and this is mass of m mass. This is r. Okay, and you can say this is your theta. The radius of circle is a. So radius of circle is a. So what you have to do? You have to just find what are the nature of force, or you can just prove Fr is proportional to 1 by r to the power 5. So you have to prove that thing. So how you will go for it? कैसे जाओगे इस पर? Anyone?
Suppose we will find r r equals to a cos theta.
Okay, r is
And
equal to
then we
not
will
a
solve
cos
that.
theta, but r is equal to 2a cos theta. Look at. This is
Oh,
a,
yes, yes,
this
yes.
is a. You can put the perpendicular here. So this value is a cos theta, this value is a cos theta. So can I write r is equal to 2a cos theta? Yes or no? लिख सकते क्या?
Yes, sir. Yes, sir. Yes,
Yes,
sir.
we can write r is equal to 2a cos theta. So now you have relationship between r and theta. So once you have relationship between r and theta, what will be your u? Is 1 by r, and this is nothing, 1 upon 2a, and 1 by cos theta is nothing but what? Sec theta. Yes? And now we can use the differential equation. What is differential equation? बताइए क्या है? Minus j square u square upon m d square u d theta square plus u is equal to f 1 by u. Yes? Okay? प्लीज म्यूट कर लीजिए, किसी का बैक से आवाज आ रही है ना, म्यूट करके रखिए, ठीक है? Okay. Now the most important challenge is that we have to calculate this thing, and you have to very much conscious about this particular problem. So this is j square upon m. What is u square? This will be sec square theta by 2a whole square. Now you have to go for d square u upon d theta square. Look at calculation is very interesting. So du upon d theta is 1 upon 2a, that is sec theta tan theta. Yes or no? And second derivative is, and second order derivative is d square u upon d theta square is 1 upon 2a. Again you will differentiate sec theta. So what you will get? Sec theta tan square theta. ठीक किया हूं या नहीं? Just check करो. Plus sec theta remain constant, you will differentiate tan theta. What you will get?
Sec cube.
Sec cube theta. Now we will put it here. So very, आपको बहुत ही conscious रहना होगा. You have to take 1 upon 2a. This is sec theta tan square theta plus sec cube theta plus u is also there. So 1 upon 2a sec theta must be equal to f1 by u. Clear है ये? So it's look little bit clumsy, है ना? ज्यादा कुछ expression आ रहा है. What you will do? I can take sec theta common ले सकते हैं, और 1 by 2a भी कॉमन ले सकते हैं. So I can write minus j square upon m, and this value is sec cube theta upon 2a whole cube. and inside bracket we have tan square theta plus sec square theta plus 1. This one is a very good thing. Why? Because tan square theta plus 1 is equal to what? Sec square theta. And now we can have f1 by u is equal to minus 2. 2 is why? Because 1 sec square theta and another 1 plus tan square theta is sec square theta. So you can go for 2j square upon m, and you can go for sec 5 theta by 2a whole cube. Isn't it? Now what you will do? Next क्या करोगे? You will just replace sec theta is equal to what? 2a into u, isn't it? So you can write f1 by u is equal to minus 2j square upon m. I have 1 upon 2a whole cube, and you can write u to the power 5 and 2a to the power 5. And now all other term, this thing is basically f1 by u is equal to minus 2a to the power cube, 2a square by m, and you have u to the power 5. I can put this whole thing as k, some constant. So f r is equal to minus k r to the power 5. Look at here. It's so beautifully written, isn't it? fr की वैल्यू क्या आ रहा है? माइनस के r to the power 5. Okay? Clear है ये?
Yes.
So
Yes,
I am
sir.
just giving you one homework, just उसे try करो करने का, है ना? And next class we will go for a very important topic, that is Kepler's law. Kepler's law में जाएंगे and वहां पर हम लोग कई चीजों को देखने की कोशिश करेंगे. Okay? So just a minute. Chalo. This is in the JEST 2016, very nice problem. R is equal to A1 plus cos theta. R की वैल्यू क्या है? A1 plus cos theta. So what is the nature of force? Okay. Fr is proportional to R to the power alpha. Find the alpha value of alpha. So this is your homework. Just do it and post it. Clear है ये? Okay. So just try to do it. So this is your homework, and tomorrow we are just going to start the Kepler's potential. We will see how we can solve the Kepler potential and how we can, all the theory whatever we have learned, we will use to understand this thing. So tomorrow is the day of Kepler potential. If time allows, we can go for Kepler's law also. Okay. Thank you.
सर r is equal to 2a cos theta
Thank you.
कैसे होगा?
2a cos theta कैसे होगा? क्या हो गया?
सर एक बार समझा दीजिए.
अच्छा, सॉरी मुझे लगा क्या हो गया भाई. सॉरी. ये देख लो, ये तो बहुत सिंपल है. ज्योमेट्री क्लासिकल मैकेनिक्स में ज्योमेट्री बहुत आसान है. ओके, ये है आर, ठीक है? बोलो हाँ या ना.
यस सर.
हाँ, ये है थीटा. बोलो हाँ या ना.
थीटा. यस सर.
ये है ए. बोलो हाँ या ना.
यस सर.
ये भी है ए. ये क्या होगा?
a cos theta.
ये क्या होगा? ये, अरे सेंटर है ये. ए होगा.
यस सर.
ठीक है, इसका इस पर से परपेंडिकुलर पर डिवाइड करोगे. सो दिस इक्वल टू दिस. क्लास 10th में पढ़े होगे ये,
यस सर.
है ना? नाउ व्हाट इज दिस वैल्यू? ए कॉस थीटा. इसका कंपोनेंट इस डायरेक्शन में ए कॉस थीटा,
cos theta.
एंड दिस इक्वल टू दिस. सो आर इज इक्वल टू व्हाट? 2a
2a.
cos theta। ठीक है,
Thank you, sir.
वेरी गुड,
Yes, sir.
है ना? क्लास 10th,
Sir.
क्लास 10th। हाँ
Sir,
बोलो 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 बोलो।
sir, by knowing the nature of force, sir, मतलब उसका क्या फायदा है अगर नेचर ऑफ पता है?
नेचर ऑफ फोर्स का
Means I
क्या?
just want to know. Yes, sir. Yes, sir.
ओके चलो, नेचर ऑफ फोर्स से क्या फायदा नहीं है पहले ये तो बताओ। अगर आपको नेचर ऑफ फोर्स पता चल गया तो तभी तो आप इक्वेशन ऑफ, एक बार फोर्स पता चल जाएगा तभी तो आप डिफरेंशियल इक्वेशन ऑफ ऑर्बिट लिख सकते हो, नहीं? सॉरी, न्यूटन्स लॉ ऑफ मोशन लिख सकते हो। सारे
Yes, sir.
सारे
Yes, sir.
कैलकुलेशन का जो मदर सोर्स है वो क्या है? यही तो है। पीछे बहुत आवाज हो रहा है, क्या है? ऐसे पढ़ाई करते हो? हाँ, यही तो लिखते हैं भाई। हाँ,
Yes, sir.
लिखते
Yes,
हैं
sir.
ना।
Yes, sir.
तो जब तक ये नहीं पता
Yes,
हो
sir.
तुम क्या करोगे इसका? आर
Yes,
गेटिंग माई पॉइंट?
sir.
सो पूरा का पूरा तो
Yes,
खेल ही
sir.
है कि
Means
नेचर ऑफ फोर्स
we
कैसा
can-
होना चाहिए। पूरी मैकेनिक्स का अल्टीमेट एम ही है कि भाई नेचर ऑफ फोर्स अगर हमें पता हो जाए तो एटलीस्ट हम इस तरह के सेकंड ऑर्डर डिफरेंशियल इक्वेशन सॉल्व करके आर वर्सेस टी निकाल दें। एक बार आर वर्सेस टी निकल गया तो हर एक का टाइम एवोल्यूशन देख सकते हो, नहीं?
Yes, sir. We can trace that particle.
You can find each and everything about that particular particle if you are going to solve the Newton's law of motion. And when you want to solve the Newton's law of motion, what is most important thing? You have to identify which kind of force is acting on it. Without knowing the nature of force mathematically, are you able to solve Newton's law of motion?
No, sir. No, sir.
Never, never. So once you will solve the Newton's law of motion, then only you can write R versus T. And once you will write R versus T, then you can
We
see
can,
everything. You can just go for analysis of everything. है ना?
yes, sir. Yes, sir.
Okay?
Okay.
Okay.
Thank you, sir.
चलो, आज के लिए इतना ही रहने देते हैं। कल की क्लास बहुत इंपॉर्टेंट है, हर साल यहां से एग्जाम में आता है ना? सो प्लीज उसे जरूर करोगे, ठीक है?
Thank you, sir.
थैंक यू, थैंक यू। रिवीजन जरूरी है भाई, रिवीजन नहीं करते हो है ना, सिर्फ क्लास अटेंड करते हो।